Welcome back to everyone. We now proceed to session 3 of day 5. Now, I again invite Dr. Prabhu to continue with the session 3 of the day 5. And the topic of the presentation is drone communication. Sir, am I audible?
Am I audible? Hello?
Yes, sir.
Audible, right?
Yes, sir, you are audible.
Okay. Okay. Sorry for the spelling mistake here. I'm spelling here. Okay. So in this session, I'll be discussing about some features of drone communication and its status in 5G, and also discuss about drone swarms and how swarms can be controlled by by 5G base station. What are the things we need in the 5G setup in order to support large number of drones? We discussed the things earlier, and in release 17 itself, we started working on support for the uncrewed aerial system. That means unmanned aerial systems, also called drones, right? The support for drones already should happen in release 17. That means 2020 quarter 4. Um, so in the release 18 also, uh, phase 2 is already ongoing. So you can see UAS, UAV, EAM, phase 2. So in release 18 also, it is happening. Uh, in, in the next within the next 2 years, you will be able to have the standard for the drones as well. Okay. Actually, there has been a study in 2013 itself from the US Department of Transportation about the growth of the drones. In 2035, within next 10 years, there could be a lot of drones flying around to services. There are different types of UAVs, unmanned aerial vehicles or drones. There are fixed wing UAVs and rotary wing UAVs. So rotary wing UAVs can be moved in any direction with the proper control. So fixed wing fixed wing UAVs can fly in particular direction. That is the difference. And there are different size of drones. We can see that there are small companies like Ericsson also tested the small miniature drones. It can be handheld. It can be used for surveillance and all those applications. Actually, there are different types of drones available. With the rotary wing also having four blades, four motors, and six motors with the different equipments. So depending on the size of the drones, they're called nano, micro, small UAS, ultraweight, all those things. Weights ranging from 0.5 kg to several few tons. So we are going to talk about one of the small drones, like small UAVs up to 25 kg of size. So overall size wise, 1 feet radius, um, and the altitude of the drones will be varying from 50 feet to some several hundred feet. So the small drones actually they don't have so much space to carry the battery, so it can actually fly for some 20 to 40 minutes duration depending on the battery capacity. That is a nano drones or micro drones. They can fly for less than 1 hour. There are depending on the size of the drones, number of drones in a group, they are classified into. They used for several applications. In the x-axis shows distance in meters. The y-axis shows the um, number of drones. So the drones are being used for inspecting the cell towers, um, and also pipelines, bridges. They can be monitored using few number of 1 or 2 drones. And like longer bridges can be monitored by tens of drones. And several hundreds of drones can be used for in military applications, basically. In the border surveillance and many cases, drones are used in military cases. There are a lot of applications. And we also see that for drone shows and all, they are using a large number of drones. They are coordinated way. They form some pattern to show, illuminate something, right? So a lot of applications on this. So what are the communication requirements of our drones? So whenever you are communicating the smartphones and all, there is a difference. We are in a terrestrial, right? In the ground level. The drones are flying at the high altitude, at least 30-40 feet above the ground level. So then that means that we need to give a proper link reliability in the 3D space. This is related to your antenna design, such things. Then the application point of view, they have attached with the cameras and some sensors, so they have to stream some videos. Major applications are involving the streaming the videos, right? So high throughputs are required, and the low latency is very important. Whenever you are controlling a drone, the latency is very important. If you are touching a camera and by seeing the camera, if you are by visually, if you are seeing the drone and controlling is do one thing, and if the drone is not in your line of sight, in line of sight condition, if you are seeing the video stream and controlling the drone, so the moment you are controlling the drone, by the time it may hit the some building or trees or anything. So the latency is very important. The latency between the video stream and the control you are sending, no, that has to be very minimum in a few milliseconds only. That is very important. That is very important. And power consumption also very less. And it should support very high mobility, up to 45 bits per second. And the traffic also different. In uplink, that means when you're controlling the drone, we are going to send a few bits of information, like left, right movements, all those things. Whenever you are receiving information from the drone, that is huge. The traffic from learning is huge. Several MBs of data is required. And so currently, what are the drones we are seeing? You might have seen the drones in marriage functions and some major events and gatherings. They take drones in even cricket matches and football matches. They are taking using drones to capture the real-time information, right? Video streams. And in these cases, currently they are using Wi-Fi uh, Wi-Fi signal, because the Wi-Fi is already standardized and it suits well in this application, the short range, because Wi-Fi is meant for fixed wireless access, right, for short range communication. So drones also in some cases can be applied, used, even the range within some 100 meter, then you can use the Wi-Fi. That means if you are using a single drone, this is enough. It has you cannot move the drone to high speed because Wi-Fi doesn't support high speed communication, right? It's meant for fixed mobile access. And latency also very high in Wi-Fi. So if you know that if you are adding more number of devices to Wi-Fi access point, by default it will the performance will be going poor. So whenever the large number of users involved, we cannot use for Wi-Fi. So for that reason, we need a entirely new cellular any wireless system to support the drones. And so Wi-Fi, this kind of Wi-Fi enabled drones can be used for line of sight. Whenever the drone is in line of sight, you can use it. Whenever the drone is going non-line of sight, it's far away. You will not be able to track the drone. It may go down anytime. So we come back to this again. So there are different traffic requirements for the drones. Whenever it is sending 8K video live broadcasting, we need a 100 Mbps plus data rate. And up to 300 feet height altitude. Latency is up to 200 milliseconds acceptable in different scenarios. And the drones also being used for cartography. Cartography means creating a 3D map of building structure, all those things for a building section and all, they are being used. And they also used for surveying applications. Like our survey department also using the drones for mapping the lands. They have, depending on the application, they have different latency and the throughput requirements. So when you're using drone, the control is very important. So the control information has to be sent within 40 milliseconds so that they make the directions are correct time. Movements and directions are correct time. Then we should have always 100% reliability. So link quality, if it goes down, means you will not be able to get the right, it will be lost. So as I mentioned earlier, in 5G, they are using it for using network slicing. They can support the drones because drones latency is very important. So we need dedicated service for that drones. So there is a unified traffic management, unmanned aerial system, traffic management system that will be controlling the drones. Here I'm talking about multiple drones, large number of drones that can be supported. So one of the application with a large number of drones is that disaster management. So when during disaster situations, will not be having any cell towers, right? We don't have any cell towers. If it is become very serious issue, we may not be able to get the powers, electrical power, all those things. In those situations, we can use the drones. You can fly large number of drones to inspect the situation. The security personnel, they can monitor the situation by using a portable base station, and they can help the victim on correct right time. And drone racing is another application. You can search for it. Across the globe, the drone racing are happening, where a large number of drones are, they will go to some hurdles to reach the destination. The total racing will be within 2 minutes or 3 minutes like that. Whoever is reaching very fast, they are the winner. So these are the applications involving large number of drones. So actually, I would like to discuss this my paper that I have done 2019. So how to utilize the massive MIMO technology for connecting the drones. So Massimo, you know, it's a 5G concept. It involves a large number of antennas at the base station, right? So one problem with the connecting the suppose assume that the drones are being connected anyway. As I said here, the 5G is the drones are going to be part of the 5G systems. It will be supported by 5G because uh, we have 5G towers everywhere. That means we don't have any coverage issue with the cellular system. So always continuity is there, it can be connected. But there are some issues, technical issues with the antenna system, other things that we have to take care. One important aspect is that the cellular base stations are designed primarily to support the terrestrial users. Those who are moving on the land, they get service from the cell tower. So that the, so for that reason, the cell phone towers are having the antenna system that is tilted towards ground. Always a slight tilting towards ground will be there so that users are getting a proper service. Since the drones are flying at a little bit higher altitude, they may not be able to get service all the time. So that for that reason they have to fly always at some certain low altitude. Okay, but we know that in cities and all we have high-rise buildings. That is not possible, right? You cannot always maintain the lower altitude range. We have to fly at the high rise regions. In those situations, what you have to do is we have to slightly orient the antenna system at the base station. So not only should have the base station antennas tilted towards ground, it should be oriented towards sky also, so that all the drones get coverage. Why is that is required? So because you know that any antenna system that has um, yeah, but whenever the drones are flying at the sky, that means they'll be having line of sight communication with the transmitter. In that case, the polarization will be the major issue. So we are having smartphones, we are in the ground, so we don't face this issue because we are always getting reflections from the surroundings, be it the building, trees, and all. So we will get the received signal with having multiple polarization, all kind of polarizations, horizontal, vertical, circular, all those things. As effectively, we don't see any signal degradation at the very terrestrial condition. But whenever you are in the line of sight condition, the antenna orientation matters. For example, in the left side graph, you can see there's a transmitter receiver. The transmitter antenna is oriented is a cross dipole antenna. One is in the horizontal x direction and another is z direction, and the receiver also having the same orientation. So if it is in this case, we don't face any signal degradation. Even they are very close, even 10 feet or 5 feet closer, they don't doesn't matter because they are oriented properly so that because this in the top figure you can see that half of dipole antenna pattern, no, so this won't have any null at the z direction, right? So they properly receive, there is no polarization mismatch loss and perfect match between the two white dipoles. Now consider the another scenario. The receiver is the top one with this orientation, and the plus and the sorry, the antennas are placed in y and z direction, and the transmitter is antennas placed in the x direction. Okay, and the one antenna is y direction. Now what happens is that due to the high loss, due to mismatch, polarization mismatch loss, even they are with 5-10 meters closely located, they will lose severe degradation of signal quality. This happens only in the line of sight condition. So this happens because whenever the drones are flying at a high altitude, they will be tightly connected to the cell towers. So in those situations, they will not be able to get a proper signal. If they are the antennas are aligned in this way. So basically here the y-directed antenna doesn't receive anything. Only the z-directed antenna gets in some signal. It won't receive anything from the z-directed antenna, x-directed antenna as well. Because of the reason only half of the signal is received. This is the case. This is the two antennas, right? You just assume that there is one antenna in the y direction in the receiver, another antenna in the z direction of the transmitter. The receiver won't see any signal at all. This is a major issue. Okay. So antenna design point of view, there is definitely an issue that has to be taken care. Either you go for um, circular polarizer antenna or any type of helical kind of things, that at least you receive some information. So in this case, we don't get a signal at all. So the drone will be out of sight. And there are some. So if you are having the drone, there are multiple components, right? Let us see about end-to-end latency. So there is a camera module that receive capture the videos, right? That takes some 16 plus milliseconds. Then we have to encode it. We know about encoders like MPEG or any other technique we are using it. That standard encoder takes 25 milliseconds of duration. So at least 41 milliseconds. Then transmission reception takes 20 milliseconds. So in 5G, it will be if it is 10 milliseconds, means 10 milliseconds reduction will be there. For decoding that the receiver side, we have to spend some 30 milliseconds of time. Then for display, it takes some 60 milliseconds. Total overall, the end-to-end latency is 108.2 milliseconds. So we have to carefully design this end-to-end latency in drone communication. It's very important. So assume that you are watching the video feed from the drone. And it's not in your eyesight. It is somewhere in the land side, beside some building or tree, something. You don't know where it is. But if the video feed only, you know it's moving some direction. So you are seeing some object in front, some 10, 20 feet. You are moving at some high speed, some 20 meters per second, 30 meters per second. Okay. If you want to make, if you want to avoid the hitting the object, you have to take some turn, left turn. So you are giving some command, right? So with that speed, it will with the 20 feet distance. Let's say it takes some 0.2 seconds to reach that position. But if the delay is more than 0.2 second, the control delay, it will definitely going to hit it, right? So the delay has to be minimized. Where are the place we can reduce the delay? So there is the transmit receive section, right? That there if you are efficiently designing a 5G system, there you can already we know that 5G can support a 1 millisecond latency. So let's say that is possible. And by efficiently designing the cameras, the specific camera design is possible. Using that, we can reduce the delay. So somehow we have to play around all these things. We have to reduce the delay. The communication point of view, we have control over only the transmit receive delay, right? So there you have to make a play to reduce the delay. So one issue with the antenna system, that if you are having one or two antennas, you are always having the issue with connectivity. So one solution could be use large number of drone antennas at the transmitter side. So already we know that the 5G cell towers. Currently, they are using 8 or 16 antennas, but in future they'll be equipped with 64 antennas, 128 antennas, or more than 100 antennas. In those conditions, we will be able to use this massive MIMO technique. So the idea is that when you are using massive number of antenna elements at the transmitter side, so the drones are going to be equipped with a single antenna only, right? But the transmitter side, you can increase the number of antennas. So how it is going to be beneficial? So assume that the drones, see the figure 6. There are two antennas and there are two drones and there are n number of antennas, m number of antennas at the transmitter. So on the antennas are oriented same direction, and the drone antenna also in the vertical direction means it will be properly receiving. But we know that drones are going to move in a very high speed and also may do some rotations in the sky, right? Whenever they change the orientation, the signal quality will degrade because of the polarization. Because we are assuming that it's line of sight condition. So in the line of sight scenario, they are going to, even if you have a number of large number of antennas at the transmitter, the signal quality is going to be poor. So one solution is to arbitrarily change the transmitter antenna orientation. So here the antennas can be randomly oriented so that at the receiver side you don't feel any signal quality. So the solution is to um, arbitrarily orient the transmit antenna so that effectively at the receiver side you will always the probability of not getting signal from all the antenna is reduced, right? At least some part of the antenna will give signal to the receiver so that the drone is always in coverage. We will have minimum above the minimum sensitivity level, you will get some signal. That is the one proposal we made in 2019. So this has to be experimentally verified. So we are in the process of experimentally verifying this antenna orientation concept. So currently, whatever drones we are using, that is using Wi-Fi. So Wi-Fi is not going to be used in the long term, particularly when a large number of drones are involved. So this figure shows in the left side figure shows in the azimuth and elevation directions how the signal quality um, varies over the receiver side. So there are nulls you can see, no? There are some nulls, some due to the origin. So here the transmit antenna is fixed. The receiver antenna is moving in all directions with both azimuth and elevation angles. So we are seeing so nulls with very less uh, gain. So in those in those locations, it will fall down. I mean, it will lose the connection. But if you are arbitrarily orienting the transmit antenna at the base station, you can have a response like the one in the right side. So you'll almost although any orientation the drone move, it will get a flat response. That is the advantage of arbitrarily orienting the transmit position. Either arbitrarily orient the transmit antenna or arbitrarily change the polarization of the individual element. That's also possible. Either you use linear array or rectangular array, doesn't matter. So this is always going to be beneficial. So another advantage of using large number of antennas is that suppose if you are if you are using single antenna system, you are getting some X distance coverage, let's say. So if you are using n number of antennas at the transmitter, let's say 100 antennas. So the range can be extended to square root of m times. That means 10 times the range can be extended using number of increase the number of antennas the transmitter. You see what you are thinking doing is that massive MIMO enabled drone. It's not currently it may not be able to support. In the maybe the when it comes to 6G, when we are actually deploying large number of antennas, that time the range can be extended to up to 10 times for the drones. And the throughput per drones with respect to number of antennas shown here in this graph. The x-axis is throughput per drones in MBBS. The y-axis is number of antennas. Okay. If for 20 drones and 50 drones, the blue color one is 20 drones and red color one is 50 drones. This is the throughput per drone shown here. When the drones are uniformly distributed around the transmit location, we are, for example, if you take 50 Mbps data rate, if you need 50 Mbps data rate, how many antennas do you need? So with 20 drones, we need around 120 antennas. And if you are running with 50 drones, we have to increase the number of to 300 plus. So that is the result we got using some theoretical study and expressions. So from the base paper is actually, can show that the base paper is we show that I'll send it in the chat box. It's also our earlier work only. So probably it's on first page. No, not here. Okay, so yeah, so we derived using these channel capacity expressions and assumed line of sight conditions. We assumed there's a transmitter. Around that, there is a k number of drones flying around, and how to increase the capacity and latency with a large number of antennas at the transmitter side only. So this is the one result. Yeah. So the summary, if you are taking 20 bps per drone, the k equal to 20 means k 20 number of antennas. We need around 30 base station antennas. If we are having 50 drones, then we need around 70 antennas. So the same thing goes with the large number of different bandwidth conditions. With the 200 megahertz bandwidth, this is top one. The 500 megahertz bandwidth, the bottom one. Okay. Suppose we need a very high throughput communication. We need around, if we need around 500 megahertz, 500 Mbps data rate. Nowadays we know the 8K videos, all those things are there. If you need high 500 means the number of antennas is going to be several hundreds. So this this is the study assuming that more than 100 antennas in the system. So can we do existing 5G setup for connecting the drone? So is that possible? Yes. So we have tried that one. So as I mentioned earlier, we have this test bed, right? So we have the test bed. So what we did is this is our 5G test bed with some general purpose computer for the core network and GNB, and we have some transmitter using USRPs. Then we have something called IoT bridge. See, the IoT bridge is basically a device capable of having both 5G and other Bluetooth and Wi-Fi support. So what we do is we build a drone from scratch. We know that the students can make drones from the already available using frames, motors, batteries. They make it, right? So the drone, what we did, we attached a Raspberry Pi or just Nano. In that, we attached a 5G modem. So we know that 5G modems are available in the market. So I will play the video. So we can use 5G modems like so this is the typical 5G modem. So we can use these 5G modems and we can connect it with a Raspberry Pi just Nano. For example, this one is the one. So different types of modems available. This is one of them. So using this modem, we can connect it with the Raspberry Pi. There are some hats are available. We can connect with the Raspberry Pi. Then the Raspberry Pi just Nano, this will be connected to the drone's controller. The drone will be controller called Pixar, right? You might have heard about Pixar. So it has serial ports. Serial port also ESP port. Either we can connect it to serial port or USB port. The Raspberry Pi. So the Raspberry just Nano. So now it is connected to the drone's controller, also to the 5G modem. Actually, that with the components, I had some. Okay, 1 second. Yeah. So actually, this is the drone we built from scratch. It has 4 motors, and there is this is the battery. Bottom of it, there is a Raspberry Pi attached to the 5G modem. Okay. There is a top you can see there is a in the top there is a controller. It is exactly this one. So basically the Raspberry Pi are just they are running on Linux platform. So using some Python programming, we will be able to control this Pixar controller through 5G modem. So the 5G modem is established a connection with the 5G test bed. So once it is established, you will be the Raspberry Pi will get an IP address. So we know that the 4G, 5G technologies all are based on IP addresses. So once the 5G modem is connected to the test bed, the Raspberry Pi will get the IP address. Then you will be able to stream the video from drone to the test bed. Actually, I couldn't bring that the video of how we made that. Just I can play the video only at this point of time. Actually, what it is, we first connected the setup in our lab with our test bed. We get the test in coverage, only 30 feet coverage. So we first tested the connections, everything. We are flying for some 5-6 feet. Then we changed our SIM card to Geo SIM card and put it in the drone setup. Then we try to control through internet. So then we are able to do this testing. So this we were doing in Chennai, one of the park. We couldn't fly at a high altitude, and all. We didn't go for that level of testing. But we are successfully able to communicate with them. Okay, so suppose if you want to develop some 5G enabled drone, these are the components you need. One is the basic 5G, sorry, basic drone. So these kind of frames and all available as a set, whole set in Robo any other website. You can buy it, and on top of it, you have to attach Raspberry Pi and 5G modem plus the flight control. Then you actually need a 5G test bed. So with this setup, you will be able to make a end-to-end 5G enabled system. Then you can use it for applications, video streaming, object detection, anything you want to do, we can do it. So the 5G use case labs given by Government of India, uh, they have drones delivered, but it's already built and given to the people. So you don't have any control over the things how it is built. So one approach should be you buy the raw materials and build from scratch. That is one way to build the drone using 5 setup. Actually, I couldn't get any picture from the use case lab drone, but it is similar to the one I have shown. Um, So this is it. So either you can make with four arms, or you can also make with 6 arms. Doesn't matter. The main thing is the combination point of view, how we are going to build it. So this is the overall architecture, how it works. Basically, the drone is going to talk with the base station. The 5G modem is already connected. So currently what you're doing is you'll be using the normal drones that we are building. You'll be having Wi-Fi modules, right? You have to remove the Wi-Fi module and use the 5G modem. Then you have to put your own SIM card that will be connected to the test bed, right? This can test bed. Then it will be connected to the core network components. So in the core network, we will be having multiple EPFs, right? So one of the EPF is responsible for controlling the drone and processing the drone videos, all those things. So this drone video will be processed by one multi-access edge computing unit. It will be running some Python script or something for object detection or anything else. Or if it is a smart farming application, it can capture the, it can detect the disease from the images. So if any of you have used the 5G testbed, I can explain how to do that. You can ask me any questions here. If you have any experience on 5G testbed, or if you want to know how to build the drones with the 5G capability, I can explain that. And what other things I explained here, this this antenna orientation concept, you can also verify the classic that using proper test bed alignment. So in that case, what it do is, so you have to keep the transparent antenna particular direction. We should keep the setup in the not indoor. We have to take it outdoor, where no obstacles are there. You have to move the drones in all directions. Okay, then you will be able to measure the signal quality. So the drone can send the signal quality instantaneously to uh, the to the monitor device that is installed in the web app. So in the core network side, you can have the display in real time. What is the actual signal strength? Okay, using that one, you will be able to identify the zones where or the orientation of the antennas where the signal quality is good or bad. And one more thing about uh, uh, research direction on these drones is that, as I mentioned, the channel modeling is very important. So based on the orientation antenna and all, it's very difficult to do. So uh, so current systems, whatever study we are making, is not suitable for drone communication. For that, you have to develop channel models for drones. Okay. So for the thing, you have to use the tools like ITU, documents like I2 or M2135 or 4G. For 5G, we have ITU or M2412. You just Google it, you will get the documentation in a PDF format. So I'll show you how to do that. So guidelines for evaluation of radio interface for IMT 2020. This number is M2412. For 4G, it was 2315. Okay, so you see the table of contents, you can see that there is a evaluation methodology. We have to follow this evaluation methodology. Let me download this. So actually, there are two things. One is when you are building the drone, that you're testing means you are testing with the already existing 5G standard, right? So if you want to contribute to the standard and you want to propose new ideas, algorithms in the physical layer, mech layer, all those things, right? So you have to follow this document and you have to create a cell layout, something like this. Okay, this kind of cell layout you have to create and you have to do it, do the simulation in either MATLAB or C++, and you have to consider the scenarios. For example, this is something like there are several tables are given scenarios like um, dense urban, EMBB. Dense urban means you have to use the transmitter with 44 dBm and 20 megahertz bandwidth. Okay, for configuration B and configuration B, 40 dB for 80 megahertz, such things. And you have to use a UV transmit power, drone transmit power of 20 dBm. So number of antennas the transmitter up to 256 you can use on the transmitter side. Okay, and there is the drone side up to 8 you can use. And this are urban, then this are dense urban, and so you have to consider 10 drones or 10 EUs or 10 drones. If there is a user requirement means you have to consider terrestrial communication, terrestrial scenario. But if it is a drone means you have to consider the drones are drone positioned some certain altitude from the ground level. So you have to consider proper antenna height, drone height, all those things. For the proper antenna height or base station as well as the drones. Distance, all those things are done. Then you have to use the path loss, LOS probability, shadow coding, everything you have to consider. So you have to generate the channel coefficients as per these models. So you can see some parameters like angle AS, angle spread, shadow fading SF, K value, all those things. So just to have idea, angle of arrival, angle of departure distributions, you will follow some probability distribution. You have to follow those. So by following this channel model, if you perform any link calculation, any BR performance analysis and all, then you'll get a proper idea how the drones will perform in some higher altitude, all those things. Then from the results, we will be able to propose some ideas on what kind of uh, you know uh, uh, beamforming and decoding techniques that you can use at the base station or transmit site. So there are something like a cross polarization parameters. So these kind of antennas also we can use at the, I mean, this kind of polarization model also we have to use it at the transmit antenna side. So whenever I'm talking about this 3GP standardization, right? So I'm saying that they developed the technology for this 2015 to 20 or 4G or 5G things. So they what they do, all the companies they involved in 3GP, they refer the document. This is the base document. They implement the channel models like this is my channel model, right? So it involves a lot of azimuth angle, elevation angle, and number of antennas, M. So all these parameters will be incorporated, and they will do the simulation study. The simulation will run for a few days to a few weeks because um, the language for the simulator will be written in C++. Then they will run the simulation in the server machines, right? Then we'll get a proper accurate result. Then that can be implemented in the practice. Whenever you see what they are doing is that they are mimicking the real world scenario in a simulation with accurate channel measurements and all. So this channel, the expressions, they got it from taking a lot of measurements in the field. Then they do empirical cow fitting. From the cow fitting, they derive these expressions. For example, Patla's formula, it will look like this. So if the operating frequency is between 0.5 to 6 GHz, we have to use these Patla's formulas. For urban macro. EOMA means urban macro. You have to use this 28 plus 22 log 10D. D3 means 3D position of the distance between the transmitter and the user equipment. So we have to use the 20 log 10 of FC. FC is given in gigahertz. So one thing is academically, when you are publishing papers and all, we use a simple pathless formula that is acceptable, is fine. You'll get some reasonable result. But when you're actually making the standard, contributing towards standard, we have to carefully use these uh, expressions and do it. Okay, so if any of you have done this 5G testbed based setup, if you want to learn how to integrate the drone into that, I can answer it. Any questions related to that?
Sir, there is a question in the chat box. Hello, sir. Am I audible?
Okay. Okay. Yes, yes, I will.
Sir, question is, what are the challenges faced during 5G enabled drones?
Yeah, so as I said, one issue will come. Suppose if we are connecting the drone with one 5G base station, that's fine. But when we are moving to another base station, there should be a handover, right? That handover should happen very smoothly without any interruption. So that will be a major drawback when you are connecting drones. So already you know what in Bangalore they are using drone-based delivery of medicine, right? So nowadays currently they are doing is through Wi-Fi and all. If you want to deliver it the next street or within a half kilometer, that's fine. So if we are practically launching the 5G enabled drone service in the big cities for delivery purpose, we are, let's say, delivery of goods through drones will be the first practical application in the cities. Okay, if you are if you want to deliver something for let's say 5 kilometers, okay, with that certain speed, it is going to reach the place some 10 minutes, something like that. Let's say within that 10 minutes duration, it has to go through so many base stations, right? So it has to switch between one base station and another base station. The handover has to happen, right? The handover mechanism has to be incorporated and the in the standard. So that basically who is involved? These core nodal components are involved in that.
Answer in the chat box, Ravi
Yeah.
Kumar is asking what to simulate for drone trajectory optimization for serving high-speed vehicles. Should I repeat the question, sir?
Once again.
What to simulate for drone trajectory optimizations for serving high-speed vehicles?
I mean, high-speed drones. See, the trajectory optimization and all kind of theoretical study, assuming a certain transmitter position and some trajectory. But when you actually test with the 5G or any practical thing, um, you have to use the setup, the parameters I mentioned in the document. No, you have to follow that. So theoretically, we can apply any kind of optimization technique that may work out theoretically. But practically, if you fly the drones in a assume a city scenario, um, there are a lot of factors has to be taken into consideration. As I said, one is the handover, right? Because there is no single transmitter, no, there are multiple transmitters. The drone will be moving from one cell to another cell. There will be a lot of things happening in that one. So we cannot go with fixed kind of trajectory. So if you are having a proper planning of the routes, if you take so in those cases, we should have the coverage map in the sky. So signal quality from each base station will be in this route. You know, that has to be practically measured and that trajectory has to be planned. So based on the real-time measurements, we have to make the trajectory, not on the go. So when the question is, another question is, what is challenges arises in maintaining stable connectivity during drone mobility? Okay, so we know that the we are going to use these kind of frames, right? The control information will be sent on particular time duration, uplink pilots, downlink pilot, all those things will be there. So whenever using this kind of sending information, the channel is going to fluctuate a lot. So when you are moving at high speed, particularly drone scenarios, due to the Doppler effect, a lot of challenges will happen. So the channel which will fluctuate quite fast, faster than the terrestrial communication. The channel variation that our mobiles are seeing, that will be different from the channel variation the drone is seeing. Okay, because of that, there could be frequent errors in the communication. So that is a more challenging thing that you have to do it. That's what I'm saying, that the channel modeling is very important. So once you have the proper channel model for a particular mobile speed, how the um, uh, channel fluctuates, then accordingly you have to design the frames and other things. So actually, if you refer this paper, you will get a clear idea what are the challenges with the channel modeling. I mean the Doppler effect. But if we use massive number of antennas, the mobility setup support can be maintained. Due to the properties of the massive MMO setup, we will be able to high speed communication possible because of the channel um, state information. So in order to support a massive number of antennas communication, we need to have the CSI very quickly from the drone to base station. The drone has to send the pilot signal to the base station, right? So that depends on the mobility speed of the drone. So accordingly, the system has to be framed, designed. So for the test beds, right? The test beds I have shared this one. So as whatever I'm saying, you have to make changes in the physical layer, MAC layer, and the core network side also. So someone asked about what are the tools we can use it. So these are the tools we can. So these are the five open source 5G testbed platforms available. Okay, you can use SRS RAN 5G, open array interface. Uh, that is, these are the base station protocol stacks, open source. Then this is Open 5Gs, is a core network. These are the things we can use it for sending traffic, all those such things. So there are totally three different ways of doing. One is uh, use build the drone from scratch and use the 5G modems and connect it. So here just you have the idea on how to connect the drone and all, but you can't understand how the internally things are happening. For that reason, we have to use this kind of 5G test beds whenever the drone is exchanging information to the core network or something. So the traces can be seen and if anything need to be modified, you can modify in the source code, you can make it better. So these are the tools we can use for that test beds. So the 5G use case test bed given by Government of India also follows this open air interface 5G tool. So overall, if you want to know it, the tools are like I'm seeing in all aspects. The SRS ran one thing, chat box I'm putting 5G, open air interface 5G, and open 5Gs. These are the software tools for building the test beds. On top of that, we need 5G modem and flight controllers. Like Pixhawk. Or Jetson Nano or Raspberry Pi. plus the 5G test bed. So in the chat box, I have given the overall things that are required. Both, I mean, this is all are required for any practical implementation and testing, any proposing algorithm ideas. So if you want to contribute to a standard, we have to follow the ITU RM134, say M2412. Any other questions?
Sir, I think there are no questions from the audience. So thank you, sir. Thank you very much for such informative sessions.